If you would like to learn hardware design or software programming, or if you would like to help your kids to learn hardware design or programming, this video can help you. With over 100,000 students on Udemy, Peter has a lot of experience with teaching, and in this video we are going to talk with Peter about how learning process works and the steps you can follow. So let's start.
You get a brand new Arduino in its box, single board, right? You plug it into your computer. Everyone has computers. It's 2022. We don't have to worry about that. Let's say it's covered. You plug it in. The first thing that your Arduino will do when you plug it into your USB port and gets power is LED is blinking, right? Now you ask the student, wow, look at that. It's blinking. Like, okay, it's not the most impressive thing. Kids these days have got smartphones that can do amazing things, but now you've got this electronic thing on your desk with the LEDs blinking. You ask the student, how is it doing that? And they may be clued up about programming and electronics, maybe not, but that's an opportunity for you to say, there is a little program with about 4 lines that is running inside this black device there in the middle of the Arduino that's called a microcontroller. It's actually a processor. It's amazing, but we'll talk about that later. It's not important right now. What's important is the software, we call it firmware, that is running on it. Would you like to learn more about it? The student will say, yes, I haven't heard of. The student will say no to this. Now they're focusing on the LED that is blinking, and that is exciting, right? And they just plugged in the Arduino into the computer. They didn't do anything else. Now, the next thing you do, you fire up the Arduino IDE, a very simple programming editor. Okay, people eventually complain, it's too simple. But no, when you start, it's got to be simple, because you just want to see those 4 lines, true, false, and then the little delay and the loop. You explain those 4 lines, and they seem like they're able to pick it up again immediately. Now you say, can you, now that you know and I explained how the blinking happens, can you change the rate of the blinking? Just make it double as fast, like double its frequency. And then think about it. So maybe I should change this number here from 1,000. I'll make it, sometimes say I'll make it 2,000, because I think that 2,000 is faster than with the 1,000. So I can do it. Let's see what happens. And no, the 50% that do it, the LED blinks half the rate of the original. So, oh, maybe I should reduce the number to make it half, not double. So try that, see what happens. And they try it, and it works. And now they've just completed a project. So from there, like the sky is the limit. Now the next thing I'll say is, what if you can just plug this, like control how this Arduino blinks by maybe plugging a button to your Arduino, and then when you press the button, the LED goes on. It's like the second little project. So see, that's why the Arduino is such an amazing learning tool, because from the moment you plug it in, you've got projects. Yes, Robert.
I have a question. How do you keep them interested in these simple projects? Because my daughter, she would lose interest like very quickly.
Well, good question. First of all, I've got to recognize that not everyone is interested. I have the same problem with my kids, right? I have to chase them to do Arduino stuff. They have completed half of my first course. I'll put this out publicly. My own kids, they've only done half of my first course. Arduino step-by-step getting started, that is, not the second one. And it's not a big course either. So it is a struggle. I do reckon, so I go back to the why, okay? Some people are not interested in the details. They want to understand how technology works so that they are able to use technology effectively. It's like you drive a car, you don't need to know anything about internal combustion engines or now about batteries and motor control systems. I just want to know enough to understand what a battery is, what it does, and what does it mean to have a 70 kilowatt hour battery versus a 30 kilowatt? What does that mean for you as a driver of a car? Obviously, the majority of us is in that category. Now, let's say that someone is on the fence. You've got a kid that's on the fence. I'm still trying to break the ice with my kids, so I haven't given up yet. I tried to involve them in my projects, and I realized that this is a unique opportunity that I have, because I'm here. There's my desk. Just show you. Okay, that's where I spend all my day, and sometimes nights. And every time that I do something interesting, I say, "Hey, kids, come and look at this." It could be just, a new sensor that I haven't used before, that, or maybe a little gadget that I made using wood. Like I just published recently a blog post showing my flight controllers for my flight simulator, and my kids actually were interested in this. They spent a lot of time testing it, and I actually set them down before they used it to explain how it worked. So I had a bunch of potentiometers, for example. Almost all the sensors are potentiometers, and I explained what is the role of the Arduino and how I was able to connect it to my flight simulator. So I find that involving them into my projects does help, and that's what I did in order to get them to at least complete half of my course, half of my Arduino course, that got them into thinking programmatically.
So
that's the thing that I found.
What we could say is, if someone feels like they would like to start with learning about programming or hardware design, and they find out like, oh, this is too boring because it's like too simple, they still can go and try to work on something more complex. It's just going to be more difficult. It doesn't mean they should stop. Correct?
Yeah, that's right. But just to go back to programming and electronics, I found with my kids, but also with many students, that they can deviate from the origins. Remember, I said that beginning is not important as long as you get started. And I find that my kids, for example, were playing around with the Arduino in the beginning, but then they moved towards Python. So they became interested in Python and started learning Python. They were using one of the online Python learning programs. They got through the Python basic programs that are designed for kids, with a lot of graphics and
do you have some
a lot of gamification.
Or can you open what do you use? Or?
I'm sure it's going to come up in the first few. Codecademy, yeah. So they use Codecademy. And the nice thing about Codecademy is that it's designed for people that want to learn Python and other languages, not just Python, and other languages professionally. So it's kind of serious stuff. The skills that they teach and the way that they teach it appeals to kids that are, I don't know, 12, 13 years old and older.
How does it work? And so are they creating the courses or they have?
So Codecademy has got courses that they create. They have a whole staff of curriculum designers, programmers, basically anything that's needed to create a course like this. The courses are interactive.
About the quality of these courses?
It's excellent. Like personally, if I had this when I was learning programming, like C, when I was a student, I would sign up to this.
Is it expensive?
So it's interactive. You go through it, you do the exercises. The website itself will provide you feedback. It will correct your code. It will show you where the errors are. So, for example, my kids, they didn't do this one. It's also got paths, which I like. Like, for example, if you want to become a game developer, which is very popular with kids, then there's a path that they suggest that you take. Hold on a second. Fundamentals, machine learning. Okay, there you go. Learn Python, the basics. Basics of blockchain with Python. This is interesting. Professional course. Linear algebra.
Do they have also free courses, or you have to always pay?
I believe that some of those courses are free. I'm not sure if it's been a while since I've done this. So my kids were on this last year, so we had a membership for the family that did this. This is just one. I'll show you another one, which is Australian. It's called grok. So here's what they're doing now. This is an Australian company. What I like about this particular website is that it's linked to the requirements of the Australian curriculum for digital technologies. I also know the people that part of some of the people that work on this. We've got our own school here, and my kids will teach a dashboard.
So it's like you are their teacher, you tell them what they should be doing, you choose the courses, and they should like do their homework?
Yes, exactly. In this case, look, it's late now, so they're not on. They've taken the dog out. But I would see them, that's what I like about this, is when they are on, I can see little icons here telling me that they are active.
Idea something like this exists.
And and actually what kind of activity they're doing, like when they're doing a quiz, for example. I'll show you what it looks like on the inside. Actually, not that. Oh, actually, yeah, that's what it looks on the inside. So you've got your curriculum here. Each one has a simple topic, like this one here, and there's a little bit of reading to do, and then you move on to the next thing, and eventually there's an exercise. So here's the exercise. So you run your Python script. I haven't read the instructions, so I don't know if there's something you need to do, but you learn how to print stuff out. And the next thing is that you learn how to take input and then how to progress with the language. But if you make a mistake, this will tell you there's mistakes like a regular compiler, but it runs in the browser. So for the kids, it means that they don't have to work around, or they don't have to maintain the Python installation, lower barrier to entry, exactly what the Arduino is doing. It works on laptops, desktops, low-powered computers in general, and basically it does provide instant feedback, and there's no teacher involved as well, because I found that when sometimes parent to child relation with us at home, sometimes there's a strain to our relationship. No, you didn't do your homework, do it again. This nonsense is stupid. So then there's a strain in your relationship. But when there's a computer doing the teaching, like in this case, it's all good. My kids would just come to me for help if something just doesn't work. I've noticed that no matter which tool you use, that's the other thing, whether it's grok or whether it is codecademy, or there's always bugs in the system. So a program that is perfect, oops, where was I? Here, you may have a perfect program here, you run it, but the feedback, the feedback is incorrect because of usually an instructor error when they were designing the exercise and what you're supposed to get back. So it's good to have a human.
I have another question. Are you not worried they will, if they are kind of pushed into this, that they will not like it? They will not like programming then, or something?
No, I'm not worried actually. Good question. But I think that's like this with everything. Too much of anything could eventually be a bad thing. So we choose materials that are kind of interesting to the kids, and they have a say in what they use. So for example, before doing grok, I sat with them and said, I think this is going to be a good way for you guys to learn Python. I explained what Python is. Personally, I'm a Rubyist, so Ruby is my language of choice, but I recognize that Python, because of its resources and its appeal in the market, libraries, etc., and support, is probably a better language to begin with. So I explain all that. I invest on some of the things that I know about my kids. That's why it's important to know the learner. I know that both my kids like Minecraft, for example, and they like games like all kids. So I say, with Python, you'll be able to program, to customize Minecraft, and you'll be able to write programs.
I do it very similar way. I always try to explain because my son, he is now older, and he knows he is already behind the point when it becomes interesting for him, so he can do it by himself. My daughter, she's still before this point, so it's like super hard for her and boring because you need to learn this big group of things before you start understanding how they actually work, and I think that's what is the hardest part. Try to work on something which you really don't understand.
I find that what you mentioned with your daughter, I've seen it in my kids, and actually in many of my students, especially the younger ones. I don't do this anymore, but up to last year, I was also providing training to little kids, like online training, like I did with my kids through Zoom. And I find that the initial hump in the learning curve, like it's really like climbing up a mountain, especially for not just for kids, but for any learner, but especially for kids, because kids are not trained to the stress of learning something. It's all easy for little kids, right? It's all fun. Older people hopefully have had to go through a few of those mountains, learning mountains, came to the other side, and then know that there is an end to it and it gets better. But little kids don't know that, and the thing is just terrible. I don't want to do this learning thing ever again. It's a different technique there. But I find that with a bit of patience, with the right tools, not everything will work. And with projects in particular, I think projects make the big difference. You can make that steep learning curve less steep. It's still going to take effort, but it's going to be perhaps less perceivable by the young learner. They'll get to something that, the summit, at least the current summit, because after that, you have more to learn. So there's a new mountain to climb.
I call it tripping point, where basically they understand enough so they can continue by themselves. If they are interested in this specific topic, then they will be like, I have this homework, and maybe I could make simple code and it would do it for me, and I don't have to do it. And that's the tripping point, like, oh, perfect. Yes.
Yeah.
We got there.
You're exactly right.
So basically, back to our topic, if someone is starting to learn anything, not only programming or hardware design, they have to go through this period when they have no idea what is happening or how it works, and they may be like, I don't know what to do next, just keep doing this. And then there will be the point when they start understanding what is happening, and it becomes easier and kind of natural to use it. And then
I think organization is important. Just to take this a step further, we talked about the technology, the topic, where to start, right? Like use an Arduino, for example. I'm not saying it's the only thing, but it's just a place to start. But you also need some organized knowledge. Remember, we said that students say, I don't know what to do first. Okay, I've got the Arduino. What do I do first? You can Google what to do with an Arduino and find a million different options, but those are options. Which one do I pick? I don't know. Exactly. So just pick curriculum that can present the knowledge in an organized step-by-step way. And then that reduces the complexity of this journey a lot. It's like trying to travel without a map. Like, where do I go? I know I want to go, I don't know, to my destination, which could be, say, for me, it could be Brisbane, but how? So the first thing that I do is a map. That's my curriculum.
Question. Okay, so
Yeah.
yes, basically this is the place when, for example, online courses can be useful. But again, we are in same position. Like, how do you choose one? Because there are Udemy courses, there is YouTube, there are other courses. So which one you are going to? How do you know the one who is teaching the courses is making high quality course if it's not going to be something useless? You pay for it.
Okay. Okay, now you're in a marketplace, right? That's a marketplace question. So it's like you go to the supermarket and you want, let's say, you want a bottle of milk, right? You want a bottle of milk, and you go there to the cold product section, and it's like 50 brands. Literally, I go to my supermarket here, and there's 50 brands. Maybe 40. Not only that, there are brands that have different variants: low fat, full fat, A2. There's A2, which has got some special cows that produce better proteins in the milk. That anyway, you get the idea. So, but the same brand with different variants. So you're now a consumer of knowledge, and you need to do your due diligence in order to find the right product for you. So how do you choose the right product? There are many criteria. Look at the instructor, for example. Does this instructor speak in a calm, slow speed so that you can understand the narration and the instructions that he or she provides? Or does he speak at a million miles an hour where you had to pause, rewind, and replay? So see, there's production details you need to think about. Are the visuals good? Is the way that the video runs, in which the instructor shows how to assemble something, does it make sense? Or does he or she jumps from one thing to the other, leaving a lot of blanks in the way? So unfortunately, there are ways to go around. Like, you can look at reviews, but this is a process of finding the right knowledge product for you, just like you get the right milk product at the supermarket that matches your requirements. The price is right, the taste is good, the quantity is good, and it's the right product for you. When I'll tell you what I do when I'm in the market for a product, a knowledge product, when I want to learn something, because I'm learning as well. I don't just teach. I'm a consumer of online education as well. So I look at sample lectures. I want to hear and see the lecturer so that I know that I can understand what they're saying. I look at student reviews. I look at the value. I don't trust cheap courses, and I don't trust super expensive courses. When I see a super expensive course, I feel that the instructor probably wants to make a quick buck and then disappear. I'm not saying that everyone's like that, but it's happened. I'm looking for a balance. Exactly what I would do when I go to the supermarket to buy a physical product, and then I check to make sure that the refund policy is appropriate, a few days at least, right? So there's recurse, and I also want to look at the history of the instructor. So I'll be a lot more skeptical buying a course from an instructor that has just published the first course, compared to someone who's been doing this for 10 years and like they've got a published track record and lots of reviews. It's just the safety is important there. And I'm saying all that because it's not a simple choice. Whatever you do, whatever course you purchase, you'll be spending a good amount of time. It's not just like the 5 hours of the course. Double that or triple that, because that's how much time you'll be spending implementing what you've learned as you are going through the course. So it's like choosing a book to read. You'll be spending time with it, so you're not going to get the time back. So yes, Udemy is a good place. I publish my courses on Udemy, but also look outside of Udemy as well. Because remember, it's a marketplace. So Udemy will attract courses of a particular, I guess, mindset, a particular type, it will not necessarily attract the best courses. So I found really good courses outside of Udemy in technology, in programming in particular, that don't exist in Udemy as well. So Udemy is one source, but not the only source. Just
my feeling is that all these successful instructors, they usually then move to their own solutions.
Yes.
So
yes,
everyone
exactly.
who is creating like good courses, they actually then also set up like their own way of selling the courses.
I'll just show you something that, hold on a second. Here, there you go. Just do a quick search. Well, the reason I showed you this particular website is because I use it to learn things like these things, right? Git for resource or for controlling of source code, text editors, command line automation, and hold on, this JavaScript, yeah, pretty much anything that, this is for me the most important resource. This is Ruby programming languages, exactly like Python, in my opinion, better, but less appreciated.
Okay.
Unfortunately, this is Ruby on Rails. You can use Ruby on Rails to actually build a whole website. It's built on top of Ruby, and so on. But anyway, the reason I'm showing you this is that if you want to learn something, spend the time to research. And now I'm talking not to kids, but to adults that, that take more responsibility in their own learning. So treat learning as if as you would looking for the right bank for you when you buy a house.
Okay, let's move to a different topic now. So
yes.
We covered how to start, for example, by Arduino, start with something simple, then keep working on what you like, maybe on your own project, which may be a little bit more complicated, except it's going to be hard, but you can use, for example, resources like online learning, which can help you. What is next? Like, okay, you know how to work on Arduino, you can build your simple project. How you move to something more difficult?
Again, there's many different ways, many different paths. I find that if we want to simplify this, potential infinite world of possibilities, I find that a lot of people that, for example, start with the Arduino tend to branch out to several things.
Okay.
So Arduino is the first, for many people, is the first foray into technology, both electronics and programming. It's amazing. A lot of people start the programming career as an Arduino electronics hobbyist. They discover the C programming language. From that, then they discover other languages like Python, for example. They get into MicroPython. Right? That's actually a path that I have seen. Arduino, C++, MicroPython, and then ESP32 as an example, running MicroPython on an ESP32. Now, what they've just done is that they have, in a way, they have broken free from the Arduino hardware or the Atmel hardware and gotten into a different hardware ecosystem. And then the brain is starting to make new connections. They learn MicroPython, they learn ESP32. From there, they could do other things. Once you get into the ESP32, for example, because compared to the Arduino Uno, it's a more powerful microcontroller, then you started thinking,
an example board of this ESP?
ESP32,
what people usually use.
So an ESP32 board such as, oh, look at that. There you go, one of those.
Okay, and how is it different from Arduino? Is it still microcontroller or it's a processor now?
It is still a microcontroller. So here's one example of what it looks like. There's a variety of different designs and how the board exactly looks like. But the point is that this device right here in the middle has got more computational power than the Arduino Uno that most people start with. It's got more memory, for example, more pins that you can connect to peripherals. It's got Wi-Fi, which is a big thing. It opens up the internet for whatever you build and for your gadgets. So that opens up ideas. Wow, I can create a environmental monitor, connect my ESP32 to a bunch of sensors that can measure temperature and humidity and things of those types, like that. And then I can send the data onto an Internet of Things platform like If This and That. And that thing can send me an email if a particular, I mentioned If This and That, I'll show you. If a particular condition becomes true, and that Zap then will send me an email to notify me about it. So the mind now has just expanded from standalone projects where you press a button and something happens right in front of you to now communicating with the internet and running little programs. In this case, these are called applets on the internet that has consequences that are programmable.
How does this work? What is it? You call
yeah. I'll show you something that I'll show you something that I did recently.
It can send you notification, for example, or something.
Yeah, let me show you, because I was working on a new course recently, and I created there's a bunch of applets here that run on the If This and That platform. I'll just pick this one. It's not running right now, but I'm going to show you what it looks like on the inside. All right, so there are two important steps with a middle step that is not compulsory. So there is an if step and a then step. So if something happens, and what that is controlled by you as the programmer, then do something else. So in this case, if there's a web request here, did you want me to explain what that is, a web request?
Yeah.
Okay, so a web request is a programmatic communication between two scripts, two programs, say, where the means of communication is a call to a URL.
So basically, you have on your board, for example, not Arduino, but the other
ESP32.
Yeah. You just call specific URL address, and this will trigger something on this IFTTT website, which can then do something what you tell it to do.
Exactly. Yeah. So my ESP32 will use its Wi-Fi interface and a special web library that is running on this more capable processor to send out a request to this URL here. It's just a URL that I could also type in my web browser, except that its payload is a bunch of numbers and fields. There's a particular language that this particular system used. It's called JSON, right? It's a common, let's call it language for computers or for programs to exchange data with each other. Don't be confused. Actually, I'll find a better example because this looks confusing. I'll look for an example. It's not meant to be that confusing. There you go. Here's a nice example, right? Okay, that's what it looks like. So my ESP32 is going to send a web request, and the contents, the payload of that request is going to be a JSON body that looks like this, usually much simpler. It's going to say here something like temperature, 35 degrees. Humidity, I don't know, 80%. So that will arrive here in if this and that.
Mm-hmm.
Then I've
You
got a
can
little
use the
filter
filter.
here.
Mm-hmm.
Yeah, so I've got a little JavaScript. This is a new feature in if this and that. It made if this and that much more powerful. I can use this filter to say, okay, is it above a certain trigger level, like above 30 degrees or not? And if it is above, then continue. If it isn't, then skip the next step.
Mm-hmm.
So skip. Okay, cool. If my request passes through the filter, then send me an email.
Mm-hmm.
And it will send me an email with a little bit of a small payload here, just a body, human readable. It
This
just
is nice
tells me what happens.
nice example, because
Just an example.
so when someone press a button on the board will contact this website, and this website will send you email like someone just pressed the button on your board.
Yeah, exactly. But it's not just the email. The email is just easy to demonstrate in a hello world example. But look at all these other services. Like there's a lot of other things that you could potentially do. Like if you have a fan connected to a smart plug in your home, then if this and that can send the smart plug a message to turn it on.
Oh.
Right, there you go. Remove smart plug. Right,
so
turn
this
on,
website
turn off.
can talk to this brand of smart plug, yeah?
Yes, or you could have an air conditioner that has a interface to if this and that, and then automatically you can programmatically turn it on and off. You can set its temperature settings and other settings in the air conditioner. Actually, I wonder if there is one. Air conditioner. There you go. Something, right? So this is what the Internet of Things really is all about. And the Arduino, if you go to just to talk back about the Arduino, like how the Arduino has evolved in this space that we're currently living in, from where it started with this Arduino Uno device, which was just a standalone thing that could do simple things, to now being a Internet of Things platform where you can plug in your compatible devices. And basically the devices are just sitting in the periphery of the cloud, okay, of this whole system. They're in the periphery of this cloud. And then these are all the devices that I've got connected to this cloud, and they can show me things such as, current humidity, temperature. I even have a chat. Hello world. Now this appeared in I'm not sure if I can show you this. Let me just I will attempt. Oh no. Oh yeah, I think I can. Sorry. It's going to move a little.
Okay.
So move the camera around. So that hello that I just typed now appears right here, right? And that's connected to an MKR 1010, which is Wi-Fi capable. The data that you see in the widgets in this dashboard come from this sensor, right? Yeah. So that's just an example. So I think that if you are looking for inspiration on what you can do after you learn the basics, whether it is with the Arduino or something else that you get started with, I don't think you're going to get bored. If you are someone who is interested in learning technology, I'm not saying programming anymore because everything is blended together, there's no way you're going to be bored. The important thing is to get started. Arduino is a good place to start, but we've got Internet of Things. We've got Wikipedia. We've got online courses. We've got cheap hardware. Hopefully it will remain cheap, because even the problem with hardware is it needs transport, and transport right now depends on
and chips.
There's just, the sky is the limit. The problem is how to just focus on one thing to get really good at it.
I have another question. You open Arduino website, but we are not working with Arduino board. So basically, what is happening here?
The board that I just showed you is Arduino.
Okay.
But the Arduino IoT Cloud can work with other boards, not just the Arduino. So I'll show you here, for example, I've got a few ESP32s connected.
How is it possible it can work also with other boards?
It has a small range of devices that it works with. So there's a bunch of Arduinos. So in particular, it can work with Arduino MKRs, and there's a few in the MKR family, and the Arduino Nano 33 IoT that's fully compatible with the Arduino IoT Cloud. And there's a bunch of third-party devices like these. Basically, that's it. And now under each of those, you've got variations, but essentially they're all ESP32s or 8266s and LoRaWAN. But the reason that I use, or I prefer to use Arduinos with the Arduino IoT Cloud, is because they're just better supported, especially for specialist features like over-the-air updates. So imagine you've got your Arduino somewhere on the planet Earth. As long as it's connected to a network, whether 3G, 4G, or Wi-Fi, you'll be able to update its firmware remotely. Doesn't need to be connected to your computer to do that. So that's just an example. If you use an ESP32, like in some of my examples, this specific feature is not available. It might be available in the future, but not now. But I guess, Arduino will prefer the boards to make these features available to them.
Sorry for always
It's okay.
interrupting you, but I would like to ask many questions. We still have this 15 minutes. So what I wanted to ask, okay, why do we need to, or why we would like to use the MicroPython? Why we can't continue using the Arduino environment?
Yeah, sure. So the reason for, or the use case for MicroPython, I'm going to come back to Blink later, but the reason for the use case for MicroPython is because Python is a friendlier programming language. So it is easier to learn because of its syntax. The Arduino language, so-called Arduino language, is really C, which, it's not the easiest language to learn. Arduino has simplified it a lot thanks to the Arduino library. Now, when we use the Arduino so-called language and we program the Arduino Uno, essentially we use predominantly the Arduino library, which is a collection of functions that just masquerade the complexity of C and C++ in particular. MicroPython, on the other hand, is a more modern language. Sorry, I say Python, actually. Python is a more modern language that was also designed with usability in focus. So it's a high-level language. It's interpreted, which means that the language that you write, the programming language that you write and use in the text, then gets translated into this intermediate step before it gets translated into machine code. So this intermediate step makes Python an interpreted language, which means it can work exactly as it is on many different computers. So you can take the same Python program on a Mac, no change. It will run on Windows, on Linux, etc. And MicroPython took the same concept and made it possible for Python to be used on a microcontroller.
That's why
microcontroller has to be. That's why the micro is in front of it. So it's a re-implementation of Python to run on a embedded device on a microcontroller. So the main advantage of MicroPython is that it's much easier to learn. So there's an example down here of how it looks like. Like actually, there's a complicated example. I'll go back to the blinking LED, right? So there's a blinking LED. You import PyB, MicroPython. PyB is the prototype hardware on which MicroPython worked. Now you can run it on other microcontrollers. So depending on what hardware you're running it, you import the appropriate library here. And this is how you turn on the LED. Just one line, done. In Arduino.
How do you program this? Do you need to like install special environment or because I know when you are programming your Arduino, you can install compute on your computer. You can install a software, or you can use website. You just write the software, press button, and it will flash your Arduino. So if you decide to use MicroPython, how does it work?
I'll explain. Just one moment. I wanted to finish the contrast between MicroPython turning an LED on, and then obviously to turn it off, you know how to do that, right? You change it to off and it's off, versus the Arduino, right? Not that you can't read that, but just an example of, okay, it takes a little bit more effort. Okay, now in terms of the programming, many devices come with, like the Pi board, for example, the prototype of the MicroPython language was designed to run on this particular ST microcontroller. It comes with an interpreter that is running on the microcontroller itself. So I can't, unfortunately,
there is always some kind of software running on the lowest level of the microcontroller.
Yeah. That's right. Exactly. Yeah, I wasn't prepared for this. I can't show you live, but imagine you plug this to your computer via USB, and then you take your command line, you connect to it via the serial port, and you're in Python mode. You can then type these commands, and the device, these commands will run on the device, and you get a response back.
So you work
so the
with
interpreter
this board
is
like
running on
with
it.
a computer, like standalone computer, basically.
Exactly. I actually have a course. Sorry, plug here, but if anyone is interested, I do have a course where I show you how to do that with the ESP32. Now, why the ESP32? Because it is powerful enough to be able to run MicroPython, and it's very common. Like you can get it for just like $5-10. And the process is exactly the same. If you go to download here, you'll see all the different devices where MicroPython is supported, right? This is a much bigger list than the Arduino IDE. Potentially, I haven't really counted them, but the list is impressive. It shows that there is a demand for a high-level language like Python to be running on microcontrollers like this.
I didn't know this.
Every time I come back, this list is bigger. It's crazy, but yeah.
Okay.
The process is the same.
Now, yes. Another question. How Raspberry Pi or Raspberry Pi fits into all this what we are talking about?
Raspberry Pi, right here. Yes. Okay, so the Raspberry Pi, in my opinion, is not in the same category as the Arduino because it's not a microcontroller or the ESP32 or the ST microcontrollers. So the Raspberry Pi is a computer. Okay, it's a full-on computer. The difference is that it doesn't come in a nice computer case that we are used computers to come in, and it's much smaller. There is a provision, of course. Let me go into one of those a bit closer so I can point out a few things. Okay, yeah, let's take this one for example. This is the most common Raspberry Pi, the Model B, the latest one. So the reason that the Raspberry Pi became important in the maker world is because of these pins right here, the header. So through those pins, you can connect external devices similar to those that you connect to the Arduino. Like you can connect a relay, for example, a sensor, buttons and LEDs, just like you would with the Arduino. However, it is not a microcontroller, it is a computer. And that means that to control those devices that you connect there, you both need to be a lot more careful not to damage the computer. Okay, it doesn't have the same tolerances that a Arduino does, so you can easily damage it. But also programmatically, now you have an operating system which increases the complexity of simply blinking an LED, I don't know, 1,000 times. Like, remember I said with the Arduino, you plug it into your computer, when you take it out of the box and it blinks, ready to go. With the Raspberry Pi, it's not like that. You have to install the operating system. You have to put in a programmable, an external LED very carefully so you don't burn your computer down. You have to either connect a keyboard and a screen to this computer or connect to it via a serial interface. You need to learn how to do that. You need to learn how to use Linux. You need to learn how to either use C to control your connected LED or Python. It's just a whole different proposition there.
So why is it
not
so
good for
popular?
Kids. Because there's so many people that already know all of those things, right? But a kid like my kids wouldn't be able to use this to begin with. It's not a good start for them. But for someone who already knows how to use a computer, already knows how to use Linux, is comfortable with the command line, because in most cases makers will use a command line, then for them it's great.
So you now have Raspberry Pi more like for these software people, and the other boards what we were talking about, they are more for hardware people?
Probably the distinction I would make would be in the kind of projects that you are interested in and the level of knowledge that you have. The Raspberry Pi is for people that have more knowledge across the board. So you need to have a better understanding of electronics. Remember, it's a more sensitive device, and you have a higher level of knowledge and competency with operating systems and with programming, especially Python. So this would not be your first choice. It could be your second. Like for me, I was a software person before I was a hardware person. Like I had a strange path. I started as hardware, then I completely became software, and then I became hardware again, and then with the Raspberry Pi I became software again. So it's like my path has been a little crazy. But I found that the Raspberry Pi did take me a lot more to learn, even though I had those pre-existing skills, than with the Arduino. And I find that certain things were much easier to do with the Arduino. Like, for example, plugging a distance sensor, like an ultrasonic distance sensor, to an Arduino to measure distance between the sensor and an object in front of it is just trivial on the Arduino, but it's a lot much harder on a Raspberry Pi. But on the other hand, with the Raspberry Pi, you can attach a touch screen interface on it, plus a relay, plus a bunch of other things, and have a home control system using a touch interface, which you create. Like you don't buy it from, like you create it. You can use the Arduino as a component of that home automation system, but the brain and the control panel would be controlled by the Raspberry Pi. So I see the Raspberry Pi and the Arduino as complementary to each other, but it's more natural depending again where you're starting from. But for most people, it would be more natural to start with an Arduino to get the electronics component sorted, and then you go to the Raspberry Pi to get that power that comes from the operating system and the computation capacity on it.
Yeah, I think what makes Raspberry Pi kind of hard is you need to understand how the operating system works. You need to have like more knowledge about building higher level applications, maybe, because you would like to you can run, for example, object recognition or object tracking. You can connect the
Yes.
cameras. You can
Yes.
create nice GUI. So because you can connect display, you can connect monitor. With the Arduino and the smaller boards, I think this would be like super hard maybe, and it would not look so nice as if you use it on Raspberry Pi. So it's like a little bit higher level programming for me, but still you are working on, you can work or interact with hardware level, which makes it difficult because you may want to understand also, I don't know, drivers or Linux or how like this Linux operating system works, which may be difficult to learn.
Yes, that's right. Also, yeah, I agree with all of that.
Okay,
I wanted,
it's
yep.
time. So what I wanted to what I wanted to mention in this video too is that you have some courses. So what is your most popular course?
Not surprisingly, it's Raspberry Pi. Sorry, Arduino step-by-step getting started. So my most popular course by far is the my Arduino courses. I've got a bunch of them here. So Arduino step-by-step getting started is where people start with the Arduino. It's like what brings someone from knowing nothing about electronics and programming to actually being able to create simple gadgets that to take measurements using sensors and show those measurements and those values on screens, which is pretty amazing. If you told me that that would be possible at a beginner's level when I was studying engineering at university, so no way.
And which one you think is like super cool and like super interesting one? Which one you would like to? Let's say you have you know some basics, but you would like to learn a little bit more. So which would be like the next one which you would choose?
Interesting. Okay, there's a path which basically says start with the zoom in a little. Start with Arduino step by step, getting started. Then learn a few electronics using. There's another course, basic electronics for Arduino makers, and then get into other stuff. So I've got Arduino step by step getting serious because I made this course to be a resource. It's not meant to be done from front to back in one go, but to keep it aside in case you need something out of this course as you go through your projects. So it contains lectures that show you how to use a keypad, for example, how to set up a small web server on your Arduino, how to control an RGB LED, things like that. So it's a resource like an encyclopedia, right? You don't read an encyclopedia from front cover to back cover. But then it's all about projects. So for projects, I've got more than what I'm showing here because I did this little diagram a while ago. But some simple projects that you can play around with would be to convert your old remote control car into an Arduino powered remote control car. So you remove all of its electronics and you replace them with an Arduino and with Arduino related sensors. So that, for example, your car can detect an obstacle and stop instead of bumping into it. No matter what you do, it won't bump into the obstacle. I've got another project, this project down here, zoom in a little more, that is, think of it as an introduction to robotics, because what this does is a wheeled robot. It's got an Arduino on it with a bunch of sensors. It will detect a path in front of it so that it can, and its objective is to get as close as possible to a light source. So I've got a flashlight, and then I've got obstacles on the floor, and the robot will try to get as close as possible to the flashlight while avoiding those obstacles, and it will do that autonomously.
Again,
Yes.
I have another question. What I find like super hard in robotics is the mechanics. So how people can follow your course if they need to build also the mechanics.
This particular project, mechanically wise, is not challenging at all. So
Is it
the
possible to
chassis.
buy it or 3D print it or?
Let me find a better image. Just give me a second, so you can see what the robot actually looks like.
Because I remember when I was like, I don't know, 10 or 15, I always wanted to build a robot, but the hardest thing is to build the mechanics and put it all together and find the wheels and you know everything.
You are correct. Yes, I was like that. I was into, as I said, electronics and software. Anything to do with mechanical bits and pieces was a bit more challenging. With 3D printing is not as difficult anymore, but now you have to learn how to do 3D design, right?
But that's what is really cool. I love it,
yeah.
actually.
Oh, it's much easier now, especially with tools like Tinkercad. I use Tinkercad to just quickly put together a little design, like even this. I haven't done this in 3D. The chassis here that you see, the blue components, and those wheels and the motors that you can't see, those you can get them on eBay.
Mm-hmm.
Nothing challenging here. The sensor, this is an ultrasonic distance sensor, standard or eBay. This platform on which the sensor sits, also eBay, but there are also designs you can download and print it yourself if you don't want to buy it. Now, the other thing, there's only two things that are moving. So there's a servo motor down here, which is just sitting on the chassis, nothing special. And I've just used a screw to attach this assembly onto the servo motor. So no special mechanical skills there. The motors that are powering the wheels are full rotation servo motors. Again, they're not regular DC motors, but simple servo motors that don't have a limit, because a normal servo motor has got a limit around 180 degrees. These can go forever. And the nice thing about the servo motors is that they're very low power, which means that you don't need a motor power circuit.
That was my next question, actually. I see the additional hardware or additional board which you need to actually build this.
Here's better pictures of this. So these are the parts, lots of screws, but no, cheap, right? Nothing. And I've got a list of components you can purchase. So mechanically, it's very simple. If you can use a screwdriver, then you can do this project, right? It's not a problem. And you're going to learn a lot about mechanical components as well, because like it's not as hard as IKEA. If you can put IKEA furniture together, this is easier. You will learn a few things about power, even though nothing complicated. I'm just using AA batteries. The project starts from zero. I assume that you've done a little bit of Arduino work and you know how to connect things together. I'm not going to show you how to do the breadboard. You've already learned that. But there's your Arduino Uno. There's a breadboard. There's a distance sensor. You learn how to use that. You program it. Then you put it on the chassis. This is an example of what the robot does. So there's a light source. Like I'm going through a whole series of testing. Through each testing iteration, I improve the program that is running on the robot so that it can achieve its purpose and its task better. To make things easier, because eventually, hold on a second, zoom in even further. Eventually, you want your connections to be reliable. So eventually I show how to remove all the connections from the breadboards with the flimsy wires and put them on a nice prototyping board. So I didn't do this KiCAD. I just took a proto board and soldered the components on it. And I show how to do that. And now you can plug that onto your Arduino. You can see it's on the top part of the Arduino, like a shield.
Yeah, I've seen it on the first picture.
Yes,
on
up
the
here, and that's what it looks like. I've got a Bluetooth dongle here so that I could do remote control. And I could get readings from the sensor on my computer via the Bluetooth serial interface, which is also pretty cool
This
to
must
be able to do
be a
this.
lot of work for you to create this kind of course.
Yes, those types of courses really, like, they're not easy. They take months. Like, to explain concepts and to explain what it is that you're trying to achieve as a student and as a learner and programmer. Like, I spent a lot. This is an example of an animated slide in Keynote. Light source up here, robot here, like things are moving in the actual lecture. Just this can take me easily 1 or 2 days to design and then to present it and record it. Schematics are all there. Remember, a good course is also can also stand apart because the instructor takes time to make sure there are no gaps in the knowledge of the student. You're not jumping from one thing to the other without providing some kind of bridging between the steps that you're taking.
This is something what I find actually super hard, because then you have people with different level of knowledge, and then some people may complain like it's too detailed, and the other people it's too slow.
Yes.
And it's like, okay, so jump ahead or play
fast forward is an amazing feature. Yes, I initially when I was a new instructor online, I got complaints like that. They were telling me you're too slow, and I started feeling a little bit skeptical. Maybe I'm not good enough about this. Maybe I should, maybe I'm too boring. But I realized that actually you can't create a course for everyone. You create a course that is perfect for a small number of people and not appropriate for many, many others. But that is okay. If you try to build a course for everyone, it's really going to be not good for anyone.
Yeah, and I think it's not possible, actually.
Yeah. So I'm happy with my slow pace. It pays off for the learner in the short term, not the long term. Like, the learner will finish the course without gaps, and that's what the goal is. So anyway, this is just an example. I'm just showing this. I'm not saying this people should do this course, but this is an example of a kind of more interesting and non-trivial project that someone who has basic working knowledge of the Arduino can actually attempt. Definitely not easy, but very rewarding once you finish it and you have a robot working on your floor, achieving its task. And it's the student then says, well, I made this. Students very often, excuse me, continue this project with other features. So I want my robot now to be able to listen, like to be able to clap my fingers, and the robot to detect where that sound came from and try to approach it. Much harder than the light with the sensors that are available, but still possible to do. And so on. I can go on and on forever here, but it's just so many things.
Okay. Yeah, I really enjoyed talking to you. It's a shame we only had so little time for this. Because I wanted to mention, for example, also like KiCAD, or talk about some other things, because that's something what may be important for people to learn when they would like to do something in hardware design or 3D software. We already
3D printing, yeah, for sure. Like, sky's the limit. Like, I had KiCAD prepared as well, but I'm just going to mention really quickly that this is something that students that I've known, are familiar with their path, decided eventually to do, because they were working with microcontrollers like the ESP32, which are more capable and you can do more things with them. And then the breadboards started becoming more complicated, and the circuits that they had on those breadboards, like, I had wires everywhere. I said, there's no way I can keep this hardware in a reliable working order. So I've got to formalize things by building a circuit board.
Oh, this wire is disconnected.
Exactly. And that's where this comes in. Usually it's an not an afterthought, but something that comes in a few years later, and people become serious because the projects become bigger. And that's where PCB and design software comes in. And then just before we finish really quickly, Tinkercad.
So
I
this
find
is the 3D
that,
modeling software. What do you use?
it's one example that I use because I don't have time to learn something more sophisticated. So I do what the kids do. And I love it. It's really good. So here's, I got into Tinkercad. So this is my account. These are the kind of things that I built. Nothing fancy, right? For some more complicated stuff, just like with the Arduino ecosystem, you can get existing designs that you can then modify. So here's something that I did in the past. It's just an Arduino holder that somebody else did, and then I imported and modified in my project. And it just looks, let's wait for it to load. Okay, there you go. And it looks like that, like 3D design. You can move things around, just make things fit. Then you can export this and print it in your 3D printer.
I see you can adjust the sizes or something. Or
yes, yeah, you can adjust anything, anything to do with size, shape, you can do. This is something that I did. Like, it's extremely simple, right? But I did this because I have to go back to my website for a second to see what I'm talking about here and how all this can help. Okay, so this is my flight controller project that I was talking about earlier. So I'm not sure if you can see that from this angle, maybe. Yeah, okay, I'm going to zoom in. So see this blob here that comes through this blue ring. Okay, this thing here holds the left pedal in place. So these are this is one of the two rudders that I've got on the floor to control my virtual plane.
So it's like a big
this thing here,
emulator or big setup for feet and.
Yes, exactly. So this is another view of the same device on the floor. Do a zoom out so you can get the full picture. If I can, here it is, right here. Okay, this thing here. And right there are two of them, are these two plastic, they look like nails, but I didn't have something to hold the rudder pedal in place. I needed something to hold it in place. So I went to Tinkercad and I designed this thing here, which is simply a cylinder with a cap on it. And I printed it. I had to do a couple of iterations because I need to get the size just right. And there you go. This took me 5 minutes to print.
Nice.
With no knowledge and training of CAD and 3D design, it works perfectly. And now I can fly in my virtual plane and it works. Everything else I got from someone else, right? Everything else I got from some other maker. I've got all the details here if anyone is interested. Who put his designs up on the web. Let's see if I can put it up because I think it's worth shouting out people like that. Michael Recton. So this guy here. And I just put a little bit there, which was this. This is my contribution to his design.
Nice. I use Fusion 360, by the way, and it was
pain.
It was pain for me to. It took so long
to learn. Yes.
Not to learn, but force myself. Like, yes, I want to spend time learning this software, and I had to come up with a project which was interesting for me. And when I come up with this project, I was like, finally I can learn how to design 3D stuff.
You need a project. Project is powerful. Just want to show you this because you mentioned, FreeCAD. This is what I'm trying to learn, right? This is like Fusion 360, but free. It's like KiCAD. That's why I like it. Parametric design software, but I just haven't been able to find the time to learn it.
Many people recommend this actually.
Yeah.
When I was deciding on what kind of software to learn, I went for Fusion because from my experience, very often the commercial software is, I feel like more secure learning commercial software for future. And I wanted to learn something what is not basic, because once I invest my time into learning software, I would like to be sure I can design anything in that software, because I don't want to take a free software from internet and then find limits and then have to learn something different. No, I'm not going to spend time.
I follow. Yeah, I follow you. I use the same. I have the same approach to this as I do with anything that requires a big investment, whether it's money or time, and that is research. So for FreeCAD, for example, I've been looking at this for years, not just yesterday, like just with similar to KiCAD. I've been looking at KiCAD for many years until I decided to just put my time and my effort in it. So FreeCAD, look at this, it's version 0.19.3, but this is very deceptive because FreeCAD has been around for maybe 10 years, maybe more. So there is a lot of stability in this, and it probably will be my 3D design software of choice. I like this, as you said, the stability and the safety of commercial software. Lately, things have gotten a little bit objectionable when it comes to restrictions and cost. But I guess it's a matter for another discussion. But I guess I'm shopping around. If I was doing this commercially, I would probably go with Fusion 360. But as an educator and hobbyist, I find that would be a challenge for many of my
I don't
students.
use it commercially. I use the free license on Fusion 360. If I would have to use it commercially, then I would pay license. And I agree. Today's software is hard because I don't like everyone is moving to cloud and everyone wants subscriptions. And you don't know what is going to happen tomorrow. But
it's login and formats that disturbs me the most. Like many commercial products use now closed formats that will only work for them. There's no import export. Data is, I guess, hostage. So it is. On the other hand, these are mature, very powerful kind of applications that will get the job done. There's no question about that. They will work for you. So I don't know, it's a difficult choice. But anyway, I just wanted to mention this. Just one more thing, Robert, before we finish with this recording. Like, 2 more minutes. One more thing that I find with people that are new to all this, myself included, because I always try to remember what was I like when I started blinking my first LED. It's like I felt that I was totally stupid, and I was looking at all these other super creative people. Like I was reading Maker magazine back then. It was super creative people that were doing crazy stuff. I just couldn't believe how not technically capable they were, but how creative they were, like coming up with these amazing projects and making them beautiful, and then documenting them so well in a magazine or a blog post, or making amazing videos. Oh, these people are just superhuman, they're amazing. But I find that all that comes with time. So I find that the more you learn, so in terms not just depth, becoming a better C programmer, for example, but in breadth, learning more of different kinds of stuff, that seems to just open up literally the eyes in your brain, and they do tend to automatically, if I dare say that, make you a more creative person, where now you can actually capture and generate things in your mind that you would never have 10 years ago without going through the paces of climbing a steep learning curve, getting to your first win, continuing, getting stronger with every iteration. I think that seems to have an impact in the way that brains work. And that's why I think education is, in this sense, education for the sake of education, not just for getting a better job or securing better employment and prospects in life, is hugely important.
And that's everything. I would like to say thank you very much to Peter for finding time to create this video. Thank you, Peter. And if you have any questions, or if you would like to share your path of learning electronics or programming, please leave comments, okay? Maybe other people may find them useful. If you like this video, don't forget press the like button. If you would like to see my future videos, don't forget to subscribe. I would like to thank you very much for watching and see you next time. Bye.